Good morning everyone. Alright, we've got a 3 litre 1kd Hilux in today. Now this vehicle's come in with camshaft sensor faults. Hard start, sets of cam sensor fault. I think this has just had a motor replaced in it. From here, I can see someone's already replaced the cam sensor down here. We have checked the signal output, so this is our cam signal output. Terrible photo, but we've got 2 notches, 1 notch, 1 notch, 2 notch, etc. So the cam sensor output itself looks good. 2 options from here. Good signal output. ECU's already been removed. Someone's got the glove box out, so I think we're just going to go straight to the ECU, check the signal input. If the signal input there is good, then we're going to pull the timing cover off and check physical timing. Alright, so 1kd timing. Now, I've timed a bajillion of these up before. Top timing mark is good, and I think I've picked what our issue is gonna be, but we're gonna try and confirm it with the scope. Now, I don't think this actually had an engine replacement. I think it had a recoat because we've got silicon down the bottom there. Our bottom timing mark is spot on. So our cam to high pressure pump timing, oh, there goes me torch. Our cam to high pressure pump timing is good. Alright, I don't know if anyone's going to actually be able to see on that mirror, but that notch is fine. Our camshaft to high pressure pump timing, as I said, is good. There's nothing wrong with it. So that means that we are most likely looking at a difference between camshaft and crankshaft. Now these don't directly time cam to crank, obviously. They time cam to high pressure pump pulley, and then your high pressure pump meshes with all the other shafts in there, and there's a bunch of gears that mesh together. Now from memory, you've got like a 1-to-1 marking on the cam to crank to high pressure pump. There's like a 2-to-2 marking on the other side, and they all mesh together. So we're going to get some proper diagrams of it to show you with this system as well. The way we'll go about confirming this is if we have a difference from known good to cam and crank, because we know our cam to high pressure pump's good, that means that there has to be a difference on our mesh gears in here where all the work's been done. So because we know here is fine, that means that if we've got a difference cam to crank compared to a known good waveform, that our timing is out in the actual mesh gears in the motor. From there, other things we've checked as well: signal back from our cam position sensor to the ECU pin, connector C, pin number 21, yellow wire is good. So we do have a good camshaft signal, both the notches are picking up, etc. So that's what we're going to try and confirm and prove now, is that it's a mechanical timing fault. Alright, now this is our vehicle hooked up right at the PCM here. As we can see, I'm going to go to the known good first because it's easier. So if we look right here, and we're going to use this as a reference point, our first double sync meets with the bottom line of the crank sync, right? If we come over to this, our first double sync on our waveform is meeting with the notch in front. So this is essentially one tooth out somewhere in relation to the crankshaft and the high pressure pump, because the crankshaft drives the high pressure pump, which in turn drives the camshaft. So there's a tooth out somewhere on those mesh gears. That's why we've got a crank sensor fault. That's what the ECU references. So that the ECU will be looking at these 2 signals, and it will be expecting this essentially, where our double notch on our camshaft, the first rise point, lines up with the drop point of the crankshaft, whereas the first rise point on our vehicle's waveform is 1 tooth back. That's why we've got no power. It's also not enough to cause any physical damage or anything like that, but it will throw it into limp mode. It will not make any power. So this thing, unfortunately, is going to have the motor out again, and it's going to have the mechanical timing sorted.